A word from this video sponsor. Got an idea for a circuit, widget, or device that you want to rapid prototype or sell? Check out JLC PCB. They offer their board manufacturing services starting at $2 for 5 boards and only take a few days from start to finish. So make sure to check out JLC PCB. And once again, thanks for making this video possible. Now let's get on with the video. Hey there YouTube, this is SJM4306 back with another project video. This time, I'd shown you guys a quick preview before of new boards I received from JLC PCB, and I thought I'd give you an update on my UV Lightbox project, as well as another board that I made. So this little board here, I mentioned before, it's just an adapter board, and what I actually ended up doing with it is I bought one of these Smd adapters, and it basically takes a QFP, I believe it's a QFP 44 maybe. It takes one of those packages and it adapts it to a dip, so it brings out all the pins so that you can plug it into a breadboard and, you know, prototype with it easier, and you don't have to solder it. You just put the chip down and then you close the latch. So I made this simple little board around it where it has its own oscillator, and then an LED for power and an LED for the pin 13 of the chip, basically. So as well as ICSP and then standard serial outputs, and it adapts it to the exact same pin out as the dip version of the chip, which I have one here. And so basically the idea was I can solder pins there and then just plug it into either one of these boards, the bootloader or the HV Rescue. And so you can actually use this to program without having to hold the chip down, which is kind of imprecise and difficult to do on these pads. Instead, all I did was I made this little board so I can easily use the socket, so I can program a bunch at once and reliably do so. So that's pretty much all this board was for, and it works perfectly. I did made a little oopsie. You can see the pins for the actual the SMD adapter itself are like super tiny. When I was making the footprint for the part, I forgot to check the diameter, so it's just whatever the default was, and they're really tiny. So actually the pins on this female 0.1 inch header adapter don't push through, so I actually had to kind of like surface mount solder them, so that's not exactly good, and if I were to flex this a lot it would probably break off, but good enough for now. And a couple other things, I like that I put this little adapter so you can see which way it plugs in. And yeah, so far I've used it over ICSP, and I've been able to burn bootloaders onto bare chips, and it's quick, easy, works perfectly. I'm very happy with this adapter. So the second boards that I ordered are these guys. I'll pull one out. And so my idea with my SLA 3D printer, I can, obviously pulling it straight out of the print vat after it's done printing, it tends to be a little bit sticky. And so what I've been doing is just leaving it in the sun, but it's sort of not the best idea in terms of I don't always get sun, and it's actually pretty inconvenient to have to wait for a sunny day. And then the rest of the time it's all sticky and I have to wear gloves when handling it. This is fully cured, obviously, because it's not tacky in the least bit. But yeah, basically with the prints, I need to set up some kind of workflow where I don't necessarily need to be tied to the weather. So my idea was to build a UV light box. So they sell strings of UV LED tape. I basically designed this little controller around it, and it runs off of an ATmega 328p, which is a pretty small, cheap microprocessor. And so my idea was to be able to plug it into the wall, 12 volt, like a standard plug pack jack, and have a little screen like an OLED, and then some interface buttons, and you can change settings and then set it to go and walk away. And after it's done, whatever time you set it for, it'll just switch itself off. And so that way you don't have to babysit it. You don't have to wait till it's sunny outside. It just does everything. So I built this little tiny board, and it's actually almost exactly the perfect size for a credit card. Obviously it's quite a bit thicker, but yeah, I put a spot for a nice big beefy through-hole MOSFET to actually turn on and off the light strip. We'll see if that's sufficient. You can see here, I put it on quite a big plane, like a metal plane there, and I put via stitching onto the backside as well, and that's isolated from the ground plane because that's actually, I believe, the drain of the transistor. And I put a cutout just to get kind of more emissivity so that it can get heat away faster. And so we'll see if this is sufficient. The transistor itself that I chose is quite a beefy one, so I definitely over-engineered that portion of it. So it should be fine, but we'll see after running it for like an hour or so. If it gets too warm, then I'll have to actually add like a second heat sink and maybe some thermal paste. But yeah, anyway, I guess there's nothing left to do except for we'll roll the montage of me soldering this together and then give it a few, quick tests, and I'll give you my thoughts on it. So yeah. So we are finished assembly, and you can see I wired everything up here. Kind of difficult to show because of the paint can height is pretty tall, and you can see the LEDs I've just spiraled inside. I'll have links to where you can get these. These are just 305 nanometer LED tape. Basically, it's adhesive backed, and it sort of peels. It's not really great in terms of sticking on there long term. I have this rotating solar stand thing, and I have my print that I want to cure. You can see just from ambient light it's already starting to turn. But yeah, this model is partially cured in the sunlight, but it still smells a little resiny. So anyway, because we have this assembled, I wanted to give you guys a quick demo of how it works. So we have our 12 volt AC input, and it goes in the jack right here. And I programmed some tunes to play. But yeah, anyway, little tiny speakers on the back here. It's just, this is a magnetic type, but you could use a piezo. I ran out of them. I put a footprint for it, but I just wired on this cell phone speaker. Works just fine. The MOSFET is an RF 530, and that's right over here. And I just have that bolted, and there's a heavily via stitched plane on the front and the back as well, just so that you can get some thermal dissipation on that. I've noticed though with the length of LED strip wiring that I have, which I believe it's something like, I don't know, it must be about a meter, maybe 2 meters, if that. I ordered kind of the cheapest one available. This doesn't even get warm, so a 530 is probably overkill. And as you can see, the screen shuts off when it's if you don't press any buttons after a little while. This has a 5 volt regulator to step down to generate the voltage for the controller, and just press a button to wake it up. It beeps every time you press a button. You can see the music note there. If I press the middle button on the home screen, it goes away, you can toggle the sound. You can see that there. So the sound is turned on right now. To access the menu, you press the left button. So if there are any button functions, they're usually there's some pictographics on the bottom. So the right one would be, it's a play sign, so that's to start the timer. To access the menu settings, you hit the left button. Now we have UV brightness, time, contrast, and exit. Exit will just take you back to this screen here. If we go into menu again, UV brightness, we can increment it in 10% increments from 10 to 100. And this sets how bright the actual UV LEDs will be. So here I have it set on its lowest so I can show you guys without blinding you and myself. So we'll leave it at that. Time, we can set anywhere from 1 minute. And if you press and hold, it does eventually accelerate. It takes a couple of seconds. And if you release, it'll reset the acceleration so that you can get kind of more fine control. This just makes it a little easier to set without having to, manually keep clicking the button a million times. But here you can see maximum time is 4 hours, 15 minutes. And the astute of you will notice that if you calculate that in terms of minutes, that's 255. So I'm using an 8-bit variable to hold that value. You can obviously extend that to 16 bits or whatever amount you want if you wanted to have this time at a ridiculously long amount of time. But I think 4 hours is plenty enough for a small timer. So we'll bump that down to 1 minute, just so I can practically show you guys without having to sit here for 4.25 hours. But yeah, you can see the progress bar at the bottom will show you, physical or a visual representation of the time that you've selected. So we got a minute, and contrast is the actual display brightness itself. You can bump that up. Full brightness is plenty bright enough. I find that on most of these screens, 10% is even plenty bright enough. So just to prolong the lifetime of the screen, I'll leave it at 10%. So if we exit back out, we're to this screen again. And if I just hit start, you'll see that the lights came on in the background here. Nice and UV. And you can see it's counting the percentage up to 100%, and the remaining time only shows increments of 1 minute, so it can't show seconds, but you can be sure that it is actually counting that down, and it'll decrement. If you have more than 1 minute, it'll decrement obviously a minute per each minute that's elapsed. You can see the pause. Well, actually, if you hit the right button, it'll turn off the lights, but it'll keep the time at where it's at. And you can resume from that point. And if you were to hit the stop button, which is the left button here, it'll reset the timer, reset the percentage, and you can start, from the beginning. The middle button still just toggles the audio. That's all it does on this screen. You can see the time's about to go out, and the light's still going. And there you go. It turns off automatically. And during any screen, if you don't touch the buttons for a little while, the screen will shut off to power save and to prevent the screen from being damaged, like burn-in. And you just click any button and it'll wake up and you're right where you were left off. So what I can show you now is, I guess I'll turn this off for starters. And I'll put this guy inside and show you that it does indeed spin as it should inside. So roughly center it. Put our little model inside there. There we go. And give me 1 second and I'll get this plugged in. And I guess I'll have to hold my camera because my stand is not tall enough. Let's give this a start. Let's see. It's slowly turning there. Now you can't access the menu unless you pause or stop it to change settings. So here we can bump up the brightness 100% and then restart it with the basically the elapsed time saved. You can see it spins much faster, the little solar panel doohickey, because it's much brighter. This is at 100% brightness. So I PWM the output through the MOSFET here, and so yep, that's rolling away there, and it's set to 10 minutes, so it'll go for quite a while, so I'll just stop it right now. So yeah, main things that I've done, I've ran this at 100% for 10 minutes, and the MOSFET gets slightly warm. The 5-volt regulator is maybe tiny bit warm, but not really anything to be worried about. So these two components are going to remain fairly cool. Probably the IRF 530 that I chose, N-channel MOSFET, is probably a bit overkill. There's an LED here that'll light up red when the actual UV LEDs are on, and it'll turn off when they turn off. So the idea is to have a metal lid for this, to actually mount this to the lid with some standoffs and properly insulated so it doesn't short anything out, so that you can close this entirely up, let it run, and you can see the state of the LED by looking at the red light here. Power light is always on. I have a programming header here. I have an optional, so this secondary terminal here, and then the NPN transistor underneath it was actually to, if you didn't have one of these solar powered rotating stands, you could actually make your own and PWM just another motor to spin. So that's currently not programmed into the firmware. It'd be easy to add. I have plenty of memory, a lot, of the resources of the microcontroller left. I can easily PWM a secondary output independently of the UV PWM. And other than that, yeah, this was actually, hardware-wise, it's actually fairly simple. Other than that, there's a programming header, and then I added headers for both the screen and the buttons if you wanted to wire them separately. If you wanted to put this in a enclosure and then just wire these using headers. And additionally, one other feature that I added was you can actually use a number of different screens. So here I have a much larger, this is a same resolution, but it's a, 2.8 inch, I believe. I have two of them, and they come in all different colors, and there are other screens that are, this is a 0.91 inch, there's, I believe, a 2-inch version, or 1.5 inch, something like that, 1.3 inch. They come in all different sizes, so the problem is they have different controller chips, and you can't just swap the screens necessarily. The software has to initialize them properly. So what I do to get around that is, if you pull the power, wait till the capacitor is drained, so wait like 30 seconds, and you press and hold one of these buttons, you can actually switch which screen it'll talk to. So if you press and hold the first button, it can connect to SSD 1306 screens like this guy. These are SSD 1309, and I believe I had it so if you press and hold the third button while powering on, it'll connect to those screens. And if you press and hold the middle button, it'll initialize for SH1106 or something like that, which is another common screen type. So I pretty much covered my bases for the three most used types of these 128 by 64 OLED screens. So whatever you get, as long as it physically fits. These guys won't fit, obviously, and the cable's in the wrong place, but I actually you could wire a ribbon just like I did on this guy and panel mount it and just have the ribbon hard soldered to the board here, or with a socket, whatever you want. So in that way you can actually reconfigure this for multiple screens and whatever you want, whatever you need. So for me, these 0.9 inch screens, or whatever they are, they're about, I think, like $2 or $3. You can even buy them in bulk for a little bit cheaper each than either really cheap, and I love throwing these in different projects. So, and I really like these dual color ones because I can have the menu be a different color, the title of the menu. So yeah, that just sort of works out just fine for me. Anyway, yeah, works perfectly. So if you guys have any use for a board like this, I'll have the Hackaday.io page up. I'll make a project page for this. I'll include the board design files, the schematic, the firmware obviously, and feel free to take the design and modify it to, if you have some application that's very similar but maybe not controlling light, maybe controlling a solenoid for like water or something, whatever you need it for, you can modify this project and use it. I just like the idea of this kind of convenient credit card style board that has multiple PWM outputs, or you don't even have to PWM, you can actually just set these full on off. Anyway, yeah, one other thing, last thing I noticed is if you run this at 100% full brightness for a while, this can actually does get a little bit warm, but it doesn't actually get hot enough for me to worry. So I think using the 2 amp power adapter, that the current limiting on the LEDs is enough that it's probably fine. I'll have to do a long-term test, like run it for 4 hours, but I'm not too worried about that. Anyway, yeah, if you guys have any comments, put them down below, comments or questions, and I'll see you in the next one. Bye.